everybody, welcome back to another summer STEM video with our friends from Lubrizol. Today we are going to be talking about something that one fairy tale character knows a lot about. You remember how Cinderella always had to clean everything in her house? The dishes, the floors, probably the walls, all the clothes. So Cinderella was probably very familiar with soap, and that is the topic of today's video. Soap. And who better to tell us about soap than our friend Todd from Lubrizol, where they make soap right here in Bowling Green. Isn't that right, Todd?
That is absolutely true. Our plant here in Bowling Green is part of making 9 million bottles of hand soap a month, and the greater Lubrizol, company is part of a billion bottles of hand sanitizer every month as well. So,
Did you say
very
1
much
billion
that
bottles
is
of hand sanitizer every month?
that is that is billion with a B. So 1 billion
Wow.
hand sanitizer bottles of hand sanitizer, and only 9 million bottles of hand soap. So we're trying. We want to get to a billion, but we got a little bit ways to go.
Yeah, and that's great because as everybody watching this knows, we as a global community are using a lot of soap and a lot of hand sanitizer right now.
Absolutely, absolutely. And we're glad to be able to make something that everyone needs right now.
And we do because, of course, if you're watching this, you know all about COVID-19 and the pandemic that we're in the middle of right now. And I know that when people have been talking to me about it, and health officials and scientists have been telling us the best ways to keep healthy, one of the things that they say over and over and over again is wash your hands.
Absolutely.
Yeah. And so that's one of the most effective ways to prevent the spread of the virus. But why? Why is that how we keep ourselves healthy? How does that stop the spread of the virus? That's what we're going to talk about a little bit more today. So, I have made a model of a coronavirus. First of all, I've got these pom-poms here. And these represent the parts of a coronavirus that actually get inside your body and make you sick, right? But these pom-poms, they're pretty weak. They're not very strong. And if I'd been thinking really hard about today, I would have tried to get a water gun for some fun effects. But instead, I just have my balloon pump. This doesn't pump water, it pumps air, which you can't see very well, but you can see the effects of it. I want you guys watching to pretend like I'm shooting water out of my balloon pump. And if I just hit this little fragment of virus, it washes away. It's not very well protected, right? So in order to ensure that the virus can get inside our bodies and make us sick, it builds a special protective shell that it puts around those pieces. And this shell is made out of fat. And then when you hit it with water, it doesn't move. It protects what's inside. But what I want to know from Todd is, why is this protective coating made of fat?
So the fat, when it's in water, especially in water, makes a bilayer. So there's a double layer that goes all around the inner parts, the delicate parts of the virus that protect it. And when it's in water, it gets particularly tough, and it allows it to move around very easily and to run into your cells and inject itself into your cells.
So water and fat don't like to mix together very well. I'm going to make my coronavirus three-dimensional, and we've got another demonstration to illustrate this for you. So fat is like an oil. It's the same sort of thing. So what I have here is I've got 1 cup of water, and I've dyed it blue just to make it a little easier to see. And I have 1 cup of oil. And I'm going to put them together into one container. We're going to see what happens. So as you can see, all of the oil is sitting here on top, and all of the water is down below. And no matter how hard I stir with my spoon to try and combine them, they don't combine. They separate out again. I can't make them go together. So if our coronavirus is protected by a shell of oil and we just put water on it, the water doesn't do anything to the oil. It doesn't dissolve. It's not like salt or sugar that will combine with the water. It stays separate. The water can't do anything to it. So Todd, how can I make the oil and the water combine? How can I make oil dissolve in water?
So you have to break it down. So right now, the oil and the water are different in that one's ionic, one has a certain structure, and the other one has a different structure that they won't dissolve into each other. But adding soap will change your fat, will change your oil, and allow them to be mixed together.
So I have some soap here, some dish soap. So I'm just going to put a few drops of dish soap into our oil and water solution. And now I'm going to stir again, and we're going to see what happens this time. And now, as you guys can see, they've combined, right?
That's right.
There's still a little bit of separation as I'm looking at it, but more soap would definitely fix that because there's definitely a point where they are starting to combine together. So the more soap I put in here and the longer I let it work, the more we're going to break down. So if you imagine, right, we've got our coronavirus molecule here, our protective layer of fat, and if we imagine that my hands are soap molecules, what they do is they latch onto our virus and they pull the shell apart and send it away so that our water can come and sweep all our germs down the drain where they can't hurt anybody. Which I think is pretty cool. So if you ever wondered how soap works, that's how soap works.
That's how soap works.
But here's my next question, Todd. Obviously, if I have virus and germs on my hands, I can't just run them underwater and hope that they go away. But everybody says I need to wash my hands for 20 seconds. And that seems like a really long time. Why can't I just put a little bit of soap on and rub really fast and be good?
You always have to remember that your hands are like millions of little Grand Canyons. There's all kinds of spaces and gaps where viruses and dirt can easily get in there and be very difficult for the soap to find them and break them apart and then surround them and wash them away. So that 20 seconds is the time that it's really going to take for the soap to really get into your grooves and really get into the fingers and underneath your fingernails and break it down and surround it and then let you wash it away.
But of course, here on Summer STEM, we don't expect you to just take our word for it. We are going to show you how it works and that it works. So this pink tub is just full of water. And I'm actually going to roll up my lab coat sleeves because I'm going to be dipping my hands in water. I am doing all sorts of fun sacrificing things. So here in this, you can see that, this black looking goop. This is just hand lotion. Came out of this bottle, but I added food coloring to it so that you could see it better. So the reason I'm using hand lotion is because, like oils and fats, it's water resistant. It doesn't want to dissolve in water. So it's a really good illustration of the germs on our hands. So here's what I'm gonna do, is I'm gonna take some of this lotion and I'm gonna cover my hands in it nice and thick so that you can all see it. You see all that yucky lotion on my hands. Now I don't have a way to get our setup over to running water, so instead how I'm gonna mimic running water is I'm gonna put my hands in this tub and I'm gonna shake them back and forth for a count of 3. And that's gonna simulate just running them under the faucet. So this is, my hands are covered with viruses and germs and I'm just gonna go run them underwater and we're gonna see if that gets this gunk off. Ready? 1, 2, 3. And as you can see, they are still covered in purple goop, right?
Right.
All right, so in between each time doing this experiment, I'm gonna dry, oh, it's so slimy. I'm gonna dry my hands off as well as I can. And I'm gonna reapply the lotion every time so that we make sure we're starting each experiment from the same spot. Just like we talked about last video, the scientific method is important. We want to make sure we're controlling as many variables as possible. So I did 2 finger scoops of lotion that time. So I'm going to do 2 finger scoops of lotion again. All right, so now my hands again covered in goop. And now I'm going to add soap. I should have brought this closer before I covered my hands in goop, but that's okay. I'm going to do 1 pump of soap. And this time I'm going to wash my hands for 5 seconds. So I'm going to count 1, 2, 3, 4, 5. And now I'm going to run my hands under water. 1, 2, 3. And look, it's a little bit better than it was before, but I've still got goop all over my hands. And running down my arms now too. Science is messy, but that's okay. All right, so this last experiment, I'm gonna wash my hands for 20 seconds. And we'll see how much of this goop I can get off. 20 seconds. So 2 fingerfuls. Cover my hands. Here you see, covered in goop. 1 squirt of soap. All right, 20 seconds this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. In the water. 2, 3, and you can still see a little bit of it, but my hands are much cleaner than they were just doing 5 seconds. So I hope this shows you guys why it's important to wash your hands for as long as people say. And if you even want to go longer than 20 seconds, it's only going to help. Right, Todd?
Absolutely. The longer the better.
The longer the better. So, Todd, is there anything else you want to tell our friends about your soap making process at Lubrizol? Anything you want to show us?
Well, what I can tell you is that the way that we make soap here in Bowling Green is that we use all kinds of different plant-based oils, coconuts, other various types of seeds, and we combine them with strong acids in order to make a soap that works and kills COVID-19. So we take all different kinds of oils, react them in a controlled reaction with acids, and we make all kinds of different soaps.
That is really great, and it's what we need right now. So remember, everybody, keep washing your hands, keep staying healthy, and keep tuning in to Summer STEM with Lubrizol. We've got a lot more fun things planned for this summer. So thanks for tuning in. Bye, everybody.